Question 4, solve each of the following for x. Check to make sure that your solution makes the equation true. So looking at A here, I'm going to go ahead and apply the distributive property first. So I'll rewrite the 2x plus 5, and that will equal 3 times 4x is 12x, and 3 times negative 7 is negative 21, and then I have a minus 24. Next, I think I'm going to go ahead and subtract 2x from both sides. I like to get my x's together as soon as I can, and that'll do that. So on my left-hand side now, I have a 5, and that equals 10x because 12x minus 2x is 10x's. And then I still have a negative 21 and a negative 25, which would be negative 45. So minus 45. I'm going to add 45 to both sides. So on the left-hand side, 5 plus 45 is 50. And over on the right-hand side, these, the negative 45 and the 45 will cancel each other out, leaving me with just 10x. And then as a final step, I'm going to divide both sides by 10. So I get that x is equal to 5. And I probably should write it this way. X is equal to 5. So x is apparently 5. And I'm going to zoom in a whole bunch, and I'm going to check that with a little red pen. So I think x is 5. That would make this a 10, and this is a 5, of course. Over here, if x is a 5, let's see, that would make this 40. Then I have a 40 minus a 7, and I got to multiply all that by 3, and then subtract 24. So let's see, on the other side, I've got the number 15, and I'm trying to see if that 15 is the same thing I have on the other side. Let's see, 40 minus 7 is 30, what is it? 40 minus 7 is 33. Oh, you know what? I'm sorry. This is definitely not 40. Those of you that are watching at home, like, hey, Mr. Robert, didn't you just say x was 5? Yes, I did. X was 5. So right here where I wrote down 40, I'm supposed to just write the number 4 times 5, which is 20. And that's going to be very helpful for me. It turns out 20 minus 7 is 13. So I'm looking at 3 times 13 minus 24. 3 times 13 is, I think, 39. And if I take the 39 and I subtract 24 from that, 9 minus 4 is 5, and 3 minus 2 is 1. Look at that. I got 15. So since I have 15 on both the left-hand side and the right-hand side, it's definitely the solution. X is 5. And I'll just put it right up here. X is equal to 5. And I'll circle that. Let's move on to part B. So part B is a proportion, right? I was peeking ahead in the textbook, and in the next chapter, one of the things they talk about is an advanced technique for solving equations is to clear or eliminate fractions. And I like that technique. In fact, if I look at this, if I were to multiply both sides of that equation by the number 6, my fractions would all go away. And you may be saying, Mr. Roberts, are you sure you don't need to use 12? No, it's 6 would do it. So what I'm thinking is I'm going to multiply both sides of this equation by the number 6. And of course, I can do that because if you have equal things and you multiply by equal things, right, 6 is equal to 6, then you get equal things. On the left-hand side, 6 times the quantity of x plus 12 over 6 ends up just being x plus 12, right? This common factor of 6 cancels out. Over on the right-hand side, I don't know if you can see this or not. I don't know how flexible your mind is or elastic at this point, but I can see I've got, perhaps I can think of it like this. I'm multiplying by 6, which is equivalent to 6 over 1. So part of this is I've got the x plus 3, and then I've got the times 6, and all of this is going to be over 2. Well, if I look at the 6 and the 2, they both have a common factor of 2. If I divide 2 by 2, I get a factor of 1. And if I divide 6 by 2, I get a 3. So what the right-hand side literally becomes is 3 times the quantity of x plus 3. It's a great technique. I encourage you to practice that, but what I did is I just multiplied both sides by the least common multiple of 6 and 2, and it eliminated all those fractions. On the right-hand side, I've got 3x plus 9 when I distribute, and over here I've got x plus 12. If I subtract an x from both sides, this of course becomes 2x, and I'll write the plus 9, and over here it's 12. And I'm going to take away 9 from both sides. 9, let's see, 9, 10, 11, 12. 9, 10, 11, 12. So that's, if I take away 9 from both sides, I think it's 3. So I was not expecting this, and I'm like thinking, did I make a mistake here? Because I'm getting that x is at this point 3/2, right? 3/2 is what x is, or I might say, I might rewrite this as x equals 1.5. I don't know. Well, certainly if that works, hey. But I'm for some reason I feel uneasy. I did. Maybe it's because I didn't show every single step. I did take away 9, 10, 11, 12. That really is 3. And I took away an x. Yeah, let's check it. Let's see if it works. Let's bring our calculator back up on the screen. And we're going to go ahead and, in this numerator, the first one I'm going to take x plus 12. Now, I'm saying that x is going to equal 1.5. So I'm going to say, last time I checked it without the calculator. I'm going to check with the calculator here. So I'm going to take 1.5 plus the number 12, which is 13.5. I don't know why I needed a calculator for that. And then I'm going to take that and I'm going to divide it by the number 6. So when I do that, over on the right-hand side, I'm using red all over the place, so let me just write it in blue. I get that the left-hand side is 2.25. Now my big question is that the same as the right-hand side? So let's try it. We're going to take the value of 1.5 for x, so 1.5, and I'm going to add 3 to that, and then I'm going to, I'm better press equals, and I'm going to divide that by 2, and I'm like, look at that, it's also 2.25. So as much as that answer may be a little bit queasy, all my concerns were unfounded. X is exactly 1 1/2.